Hello, my dear students and friends. This is Saida Anjum back again. So, I was telling everything about the organic, and now I have started about inorganic chemistry, which is important and which is not for your JE mains. So, in inorganic chemistry, you can see the order of important chapters is like P block elements, chemical bonding. When we come to chemical bonding, it is quite confusing chapter. The second one, you can see it is quite confusing chapter that it comes under inorganic chemistry and as well as in physical chemistry. And then the weightage will be high for D block and F block and metallurgy. The weightage is quite less when compared to others for your periodic table and periodicity in properties. But let me tell you, periodic table and periodicity in properties though have lower marks weightage, but the basic understanding what are oxides, what are basicity, acidity and everything, the periodic table and periodicity is very important chapter, and that leads you to understand where the element stands in which position and what it can be. It can be electronegative, it can be electropositive. In the reactions, how can it react as an oxidizing agent and reducing agent, and everything that comes under your periodic table and periodicity. If you understand periodic table properly, then only you can solve all the other chapters, though they might be in your inorganic chemistry, in physical or in your organic chemistry. Then there comes qualitative analysis. Qualitative analysis, which is like qualitative analysis of your sulfur, phosphorus and all so on. I'll go in detail when I'll be doing that chapter. And then the S block, that is having some least weightage of marks. And at the last but not the least, transition elements and coordination chemistry. This will definitely going to get at least 4 to 8 marks of your questions in JEE mains, NEET and as well as in your IIT exams. Transition elements and coordination chemistry is very most important. So, what's next? So, in inorganic chemistry, now as I said, I am going to deal with periodic table. So, this is the weightage of marks. You can see and you can take screenshot of this. So, let me hold this for a few seconds. So, you can see for JEE main chemistry, in inorganic chemistry chapter wise weightage, there will be much weightage. Sorry for the interruptions. There will be much weightage for coordination compounds, 8.33%. 8.33%, the lower left side of the circle you can see, and there will be very I mean to say maximum weightage is for coordination compounds, 8.33%, and very less importance and weightage is for classification, which I am now going to do. As I already said, though it is having less weightage, but it is important to understand other topics and other chemistry related questions and answers. And the thing is, if you go for periodicity classification, there you'll have Octave's law, Mendeleev's law, Newland's law and all. But I'm sorry, I'm not going to do that because it is very basic. You have learned that in your regular classes, PU classes. So what is important now that I am going to do? So the important is the trends. How the trends vary in your periodic table, which trends vary in your periodic table, and how they will be useful in other subjects. Other topics and other questions. So first of all, we can see the atomic radius. Atomic radius, you can see the arrow mark, yellow color in the left side extreme corner and the down of the periodic table, atomic radius. What happens to atomic radius? What is atomic radius? Then we will discuss about ionization energy. The topmost red color arrow mark you can see, and the extreme right, on extreme right you can see the arrow mark, ionization energy. And then coming to, we are going to discuss about electron affinity, how the electron affinity trends changes in periodic table. You can take the screenshot of this. It is imprecise, will give you clear idea of everything, but still again I will go in detail with the next slides. And the metallic character, that is also important. And one more which is not here is oxides, how oxides change, what are the basicity and acidities in periodic table. So moving next, as I said, we are going to deal with atomic radius. What is atomic radius? See, atomic radius is half of the distance between nuclei. It is telling about the diatomic molecule, but in general, if we see in periodic table in any element, it is like if you assume sun and planets. Atomic radius is the distance between sun and any element. If you consider any one planet as an element, then the distance between the sun and that planet, that is the atomic radius of that particular element. So what happens to the atomic radius in periodic table? What happens to the atomic radius in periodic table? You can see in periodic table radius decreases across a period. When you go down, I'll show you the next slide. When you go across a period, the radius goes on decreasing. Why it decreases? If you say, if you are in, see this one, these are the periods 1, 2, 3, 4, 5, 6, 7 are the F block elements. I have not recognized, I have not taken that here. I am taking only the SPDF blocks here, SPD blocks here. F block I have not considered. So when we see this, there are 5 periods in my picture. Actual periods are 7 and 18 groups. Wherever you go in periodic table, there are 18 groups. If we see here the balls, these balls have gradually decreasing when you go from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That means it is, if you see hydrogen and helium, they are in the first group. The electron is entering into 1s orbital, so the size decreases. The nuclear charge cannot go to, the nuclear charge is same for both the elements, so the atomic radius is decreasing. If you come to the second group, you can see lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. So these are all comes under 2s, 2p. The last, if you see the second group, as I already said, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine and neon. The final last electron entering into second group. So that means the second group itself, it is there, the shell numbers are not going to increase, so the size goes on decreasing. If you come down the group, the shell number increases. For hydrogen it is 1. If you see the first row, hydrogen it is 1, lithium it is 2, for sodium it is 3, for potassium it is 4 and for rubidium it is 5. The shell number increasing, so the nuclear charge which can reach for the last electron is quite difficult. So the atomic size goes on increasing down the group and decreasing across the period. So this atomic radius is very important, because if you understand the atomic radius, then you can easily understand what are all the factors required for electronegativity, electron affinity, and then ionization energy. These are all depending upon the size only. Few are accepting, few are some different cases, but almost all are depending upon the radiuses. So next you can see what happens next. The periodic table and the atomic radius, the trends. Now you have understood, I think. I hope you have understood the periodic table trend for the atomic radius. It goes on increasing down the group and decreasing across the period. This ball structure, if you keep it in mind, then it will be easy for you to remember the trend in atomic radius. So coming to ionization energy. What is ionization energy? Ionization energy is energy needed to remove an outer valence electron. R is missing in the outer, I am sorry for the spelling mistake. Ionization energy is energy needed to remove an outer valence electron. You can see here the red color ions present in between are protons. The blue color are negative electrons. The energy required to remove the blue color electron is nothing but your ionization energy. Now you can understand ionization energy. So there are different ionization energies, like first ionization energy, second ionization energy, third ionization energy. That is very simple. If you remove one electron, the energy required for the first electron removal is first ionization energy. If you remove the two electrons, second electron, the energy required for that removal of second electron is second ionization energy. The same way the third ionization energy. As I said, the atomic radius trend is very important to understand other aspects in periodic table. So if we see ionization energy, the first thing I said, the first ionization energy, removal of one electron. See, in lithium we have removed one electron, you are going to get Li plus. Then coming to its trend, you can see, one second, okay. Ionization energy, as I said, the red color arrow mark. Ionization goes on increasing across the period. The arrow shows increase in ionization energy, because as I said, atomic radius decreases. When atomic radius decreases, the electrons on outermost orbit are dragged towards nucleus. So the energy required to remove that electron is very high. So the ionization energy increases across period. If we come down to down the group, you can see in the down the group, the size is increasing. That means the ionization energy decreases. That means if you see the outermost electron in fifth group, the fifth group, 1, 2, 3, 4, 5, the rubidium, if you see that the size is very large, the nuclear charge on the outermost electron is low, that can be easily removed. The ionization energy required for that electron to remove is less. So that is the ionization energy across the period increases, down the group, across the group increases, down the period decreases. So next we are coming to electronegativity. So what is electronegativity? You can see here. What is electronegativity? Electronegativity is the energy, is the behavior of an atom to attract electron towards it. So that is your electronegativity. So what happens? You can see, once again I will tell you what is electronegativity. A measure of ability of an atom, as I already said, the ability of an atom to attract electrons towards it. What happens to the electronegativity in periodic table? So, electronegativity increases across a period. As radius decreases, electrons get closer to bonding atoms nucleus. As I already said, everything depends upon the radius of atom. If the radius is small, then it will love to have more electrons towards it. So, the electronegativity increases across the period. And down the group, electronegativity tend to decrease because the radius is very large. The atom is having already required amount of electrons, so they don't want to get more electrons. So down the group, the electronegativity decreases, and across the period the electronegativity increases. You can see that. The electronegativity in green, you can see the lower electronegativity, the yellow is medium, then the red is high. We have read so many times that the fluorine is having highest electronegativity, and that is so true. The most electronegative atoms in periodic table are nitrogen, oxygen, fluorine, chlorine, bromine. Please you take screenshot of this. This is very important. As you see in your organic named reactions and all, you are going to use so many reagents there it is needed, and in your JEE mains questions, especially the electronegative ascending order, descending order and all will be asked. The reasoning questions will be there on electronegativity. So please take the screenshot of this. Then next coming, we are going to deal with electron affinity. Where is our electron affinity? Yes. What is electron affinity? Affinity, the word itself says affinity is lacking. That is something not there. So what is affinity? Energy change that occurs when an atom accepts an electron. Electron affinity. Electron, they want electron. That is some kind of ionization energy only, in electronegativity only, in different way. The changes occurs with electron affinity are same as that in your electronegativity. Next, what comes after electron affinity is the metallic character. This is your electron affinity, which I said that goes on increasing, and this thing, metallic character. So metallic character, what happens? That goes on decreasing across the periods. Down the group we don't need to discuss because all are the metals in the initial groups. What is all are after the 13th group are metalloids and non-metals. You know the metals, the characters of metals. There is nothing much to discuss about that. We will go and deep discussion in coordination chemistry. So the next is, as I said, oxides and basicity, that thing. So periodic trends in oxides, it is very important. If we see any question in JEE mains, in your question paper, IIT or NEET, there will be given some oxide and they will be asking whether it is acid or it is basic. So in that form of questions, if you remember this chart, you can easily answer. The increasing acidic character. If you go across the period, the acidic character increases. See, the pink color is all acidic character. This boron oxides, carbon oxides, nitrogen oxides, oxides of fluorine, chlorine, bromine, these are all acidic. In the same way, if we consider the beginning groups, the first, second groups, they are basic in character. The lithium oxides, sodium oxides, potassium oxides, these are all basic in character. So what is next? We decided, we have learnt about oxides. Now we will go to, yes, the basic oxide, acetic oxide I said. You can take screenshot of this too. The purple color are of basic oxides, the green are of acidic oxides, and the red are amphoteric oxide. Amphoteric is they can accordingly act as acidic as well as basic. And the next thing is density. So coming to density, which is in dark purple, these are have high density compared to the white colored ones. Okay, there is no proper reason for why the density is high, low and all. It is nature. We have studied, practically checked in our labs and all with so many of our scientists, and we have decided what are all the densities of elements. So the dark purple colored one are having density more than 18 gram per cm cube. The light one are of middle density, and the white colored elements are of low density. So there is no much this thing in that. So only you have to remember which are all are having high density, which are all are having low density. So hope you understood all the trends in periodic table and all what are the things happen and important in periodic table, how they change across the period and down the group. So coming to some solving questions, I have few questions, important questions taken from so many books, checking out all the previous question papers. The first one which I have here is, you can see the first one here. The following statement concern elements in the periodic table. It is assertion type of question. They are giving you some sentence. You should see whether it is correct or wrong. Which of the following is true? You have to be very careful while reading question. They are telling which of the following is true. This question, the first one, above the recording video, here it is, the question. If you see online 2016 it has been asked. So the following statement concern, the first question. Okay. The following statement concern elements in the periodic table. Which of the following is true? If we see the first option, for group 15 elements, the stability of +5 oxidation state increases down the group, they are telling. It is true but not. So let's see our other answers. B. Elements of group 16 have lower ionization enthalpy values compared to those of group 15 in the corresponding periods. If we see for group 15, the outermost electronic configuration is ns2np3. You can hold or pause the video and can go to your periodic table and check. For group 15, the outermost electronic configuration is ns2 and np3. So here you can see the p orbital is exactly half filled, that is, it will be somewhat like this. So it requires more energy for half filled and full filled orbitals to remove an electron, that is ionization energy, that is nothing but ionization enthalpy. So what they are telling is elements of group 16, the second B option, the elements of group 16 have lower ionization enthalpy. If we come to group 16, this will change. that it will be NS2 NP4. NP4 means, if we see 1 2 3 P4. So the ionization enthalpy is here is high. The half filled is difficult to remove, but this electron can be easily removed. The ionization enthalpy for this is required is low. So the B option they have told is elements of group 16 have lower ionization enthalpy values compared to those of group 15 in the corresponding period. So this is somewhat true. This is okay. So this is not that true. Let's see the C and D options. So the C option is the group 13 elements are all metals. This is completely wrong. You can see the periodic table, pausing the video. All the elements in group 17 are gases. That is also wrong. The 18th group is inert gases. Inert gases. But not all the elements in 17th group are gases. So the option for this is, the correct option for this is B. For the first question, the answer is B. Note down the question and note down the answer and the reasons for the answer. So next, coming to the second question. The second question is below the recording video. If you see, the second question is the ionic radii in angstrom they have given N3 minus, O2 minus, F minus. I told you atomic radius is very important. If you know how the variations across the period down the group of atomic radius, then you can answer all these easily. If we see F minus, it is first ionization energy and the atomic radius will be very less compared to these two. Matlab, it is having one electron high. If you see, this is your nucleus, these are the orbits and there are the electrons. These are all having equal number of electrons, isoelectronic species we say. These are all the electrons. If we say like this, if one electron is added to a stable atom, then the size is not that big. If we add 2 electrons, the size is quite big. If we add 3 electrons, the size will be too big. So accordingly, if you see in the answer for N3 minus, there is no increasing or decreasing order. So the first answer, if you see answer A, they have given 1.71, 1.40 and 1.36. If you consider that for this for this and this for this, so this is the right answer. Let's see for the other options too, B and C and D. They have given the first 1.71 is right, but 1.36 is lesser than 1.40. For B it is wrong. For C also it is wrong. For D also it is wrong. So the correct answer is A. You can note down the question and the answer. It is asked in 2015. The same way, solve it and come to me. Take the screenshot of questions. We will discuss other questions when someone asks me the doubt on it. Thank you so much. Thanks for watching. Next video will be on physical chemistry. Hope this is useful. Hope you understood. Hope you had a great time. This quarantine, let's learn. Let's make a bigger India. Thank you so much.